originally in Spanish, 2021. What materials is the Andromedan Viera or the Toleka made of?
A nanotechnological metal. That is to say that the small molecules of the metal align themselves to form the hull. Those kinds of big ships, including this one, are made of a metal that is intelligent. You program the powder of that metal, and it takes the shape you want, following the pattern imposed by a computer. It solidifies once in place. So, for the construction of at least the hull of a larger ship and its interior in terms of the structure itself, we use that system, but not things like interiors, furniture, upholstery, cables, secondary installations, and so on. All that has to be assembled separately. It consists of having the design of the ship in the computer. First, the ship's engines are built and turned on, and because they are capable of transmitting an exact controlled frequency, they can print a high-energy hologram in the shape of the ship itself. That is, the engine forms a high-powered hologram of electromagnetic force with the shape of the ship and its structure. The nanotech dust follows the pattern of that electromagnetic hologram. Then, the dust clumps in the parts of the hologram that are more magnetically dense. That is, they turn on the engines, which in turn form the hologram of the ship to be built, and then the builder pours the metallic nanotech powder in an orderly fashion, and it just clumps where it is supposed to. It solidifies in place, forming what in itself could be compared to polymorphous titanium. In other words, the hull is a single piece with the alloy formed in place. Its tensile strength of the material is enormous and withstands temperatures in the thousands of degrees Celsius, and it also has the ability to repair itself. If it suffers the impact of something that damages it, a meteorite for example, the metal heals itself as a living organism would heal a wound, but in seconds.
Thank you very much, Aneka. Very interesting. That metal, or the powder of that metal, what is it made of? Can it be found on Earth?
It is not found on Earth. It is very high-tech. I describe it. It is a powder like the density of human baby powder. Each grain is a sphere filled with slightly protruding spikes. At each point of the powder, it has an electromagnetic direction in terms of its frequency. That is, it is a nanomachine itself. Each spike reacts in a way to repel or attract another point on another sphere that has the correct frequency, so they attract each other. Then they will tend to agglutinate in a very precise way, where each spike will repel the next molecule of powder or attract it. Who governs which spike is turned on or not is the computer of the ship under construction, and it communicates with the hologram. In itself, it is only a very advanced version of the same principle you see in the pictures. The dust only knows how to align itself in the programmed way, so even if meteorites hit it, it will only return to its original form. Even if you tear a piece off, it will just reintegrate back into the hull. Another advantage is that it does not present metallic fatigue, as it happens in normal metals such as steel or titanium itself, which forms the cracks where this material will later break. It heals the metal stress naturally, so it is the best material to build parts with high-stress materials, such as the internal turbines of a spacecraft engine.
Is this fabrication of the spacecraft as if it somehow mimics the creation of a biological organism, such as the creation of a fetus in the womb? Could you say it is like a living being?
Not really. It's just nanotechnology applied to the formation of supermaterials. When the material is molecularly aligned in a crystalline structure, transparent materials are formed that maintain the same tensile strength, or material strength, as the rest of the opaque hull. But it goes beyond this because the material can be programmed to form a crystalline pattern in some areas so that the hull of a ship remains in one piece, including the transparent parts. That is, a ship does not have separate glass in the hull, as an airplane would have, but the hull becomes transparent where there is a window, and the transparent part of the window, windshield or canopy, airplane windshield, has the same strength as the rest of the hull. A ship like this has several onion-like layers of energy shields on the outside imposed by the engines. These shields protect the ship from anything unwanted that might approach, but in addition to the shields, the hull is up to 90 centimeters thick with polymorphous titanium, and in some critical places, the thickness of the hull goes up to 2 meters.
Where do you get this material from? Do you recreate it yourself?
Yes, the material is created in the laboratory and then replicated. That is, you just have to make a nanotechnological grain of this material, and then the replicating machine copies it exponentially. You create a grain of the material, and then you have tons of it replicated. That is, as much as you need. It's like copy-paste, copy-paste.
What use do you have for this material? Only for the construction of spacecraft or other vehicles?
The applications of this material are almost endless. It has multiple advantages. Almost no or nowhere no corrosion. Resistance to very high temperatures. Automatic repair. Zero material fatigue. Total plasticity. Takes any shape. Reflectivity programming. That is, the final color of the material can be programmed or transparent.
And what is the name of this material in Taygetan?
Siganite eat L, only phonetic.
Conversation with Svaru of Era, 2019.
Do your ships run on grease, or is that just a figure of speech?
Grease in a very limited way. You use grease, for example, for bushings or internal bearings or balls where things turn, wheels or axles. We don't use bushings or bearings or grease in the axles because everything is magnetically levitated. Zero friction, zero wear. What would be the biggest difference from an engineering perspective between how your ships work and ours? All the materials are different, except for wood, I guess. Our ships are electric and electromagnetic. We don't use fuels or anything, although we do use chemical substances where necessary.
I would imagine that wood would not be used.
Yes, we use it, but we don't cut trees. In fact, there are so many that the ones that die are more than enough to supply us with wood, and there are plenty to spare. You use acid paper that deteriorates with time. We use a different way, and it doesn't age like that. But a notebook still exists here. Plastic has been replaced by resins of various kinds.
What materials are the engines usually made of? They are conductive metal, but what other properties do they have?
Of various kinds of metals, depending on their ability to withstand centrifugal forces and heat. It also depends on the motor part. Metals with different conductive or non-conductive qualities of electrical energy and magnetism are used. On Earth, they do not have these alloys, but the ones that are similar are aluminium, gold, copper, and bronze, low carbon steels, and titanium mainly.
Do you use nanotechnology or micro repairs?
Yes, we use applied nanotechnology in many of our technologies. The one that stands out the most is computational, where we use nanoparticle accelerators instead of transistors or chips.
Don't the ships have little robots directed by the ship's central computer to take care of repairs, without having to disturb the crew?
In many parts, yes, although we still prefer to do the repairs manually. It's not a good idea to leave everything to the computer, because if something goes wrong, you are in big trouble. We can send in small robots, almost nano, to find the leaks. But considering how critical these systems are, we want to do it with our hands. We don't want it to overheat because of a bad repair and be left in the middle of nowhere with no warp capability. And does the ship's AI help you with repairs? Doesn't the ship repair itself somehow? Isn't it self-programmed? Yes, almost all the components are self-repairing. It repairs itself everywhere that is critical, because it is part of the nature of metal. The computer helps repair the ship and diagnose the problem, except when the self-repair and self-diagnostic systems are the problem, as is the case at the moment. Conversation with Annika, 2020.
And everything is like titanium?
It is a polymorphous metal. It has a molecular structural density, many times higher than that of aviation titanium. But it is not titanium, although polymorphous titanium alloys are used in some things.
When you talk about density, you mean it weighs a lot less and is more resistant?
Yes, to its resistance and its molecular mass per volume of space, per square centimeter, for example.
And that material doesn't corrode like iron?
Not as you think. On the contrary, this material always maintains its integrity. You can damage that material as with a missile, and the damage corrects itself. It heals itself. It does not present any metal fatigue cracks either. It is not possible. It always heals itself.
They don't present fatigue. So there are no pillars in the structure of that ship? Everything is like metallic trusses.
No, because it is not solid, but rather the molecules remember how they should be bonded together, so a crack would close immediately. Yes, there are pillars, structural load-bearing parts, and beams, but it is made of polymorphous material.
It heals like a wound in the human body.
Yes, but it does not leave a scar.
I thought they were such strong metals that they didn't need load-bearing pillars.
They are usually strong like that, but even if they are strong, you need to use pillars and reinforcements to give the ship its shape. You are not going to just put a polymorph metal pole to hold up the hangar.
So they don't deform at higher pressure?
Yes, they deform under extreme pressure, but they return to their original programmed shape.
And with so much energy the ships have, what materials are the ones used as insulators to avoid melting the ship? How are they manufactured? A small military ship with so much energy?
The materials are polymorphic composite alloys, both metallic and ceramic. They withstand extremely high temperatures and are very light.
The alloys are metal alloys. Nothing mineral?
They are materials created in zero gravity, which are themselves nanotechnology. They are reactive spheres with microscopic magnetic attachment points, about the size of an E. coli bacteria. They look like a virus, a sphere with spikes, from where it connects to other spheres like them. And they are activated and deactivated using frequencies emitted by the computer, using the motors or secondary motors like the APU. So, the material follows the shape programmed by the computer, and the spheres are brought together to form something solid of the requested shape. Its molecular tension is several thousand times stronger than ground aviation-grade titanium, such as would be used in the turbine core of an Airbus commercial airliner, or the hub of helicopter blades.
So, for example, it's an example. Suppose a ship is captured on Earth, like Susie. Is there an option from the Taygetan ship through computers and technology to make that ship melt, so to speak, making all those materials transform the ship into a mountain of dust?
The ship simply changes its density by itself. Nothing would stop it, and it would escape. They may capture disks and primitive ships of other races, but not a modern Taygetan ship.
By itself?
Yes, all by itself because it has advanced real-time AI.
And if, for example, you all passed out on the Taygetan, would the Taygetan return to Temur by itself? I suppose it would.
Yes.
Another chat with Aneka.
How long does it take to build a ship like the Teleka? How many people are involved in its construction? Where do you get all the parts from? I mean, do you need parts or materials that are not produced in Taygeta? What does Taygeta need to import for the construction of the ships?
Comparatively, a ship like this can take up to 5 years to build. It involves thousands of people and combines virtually all the available technology of a race. The parts are fabricated in place as you would build a terrestrial aircraft carrier with prefabricated blocks that are assembled modularly. The hull is then poured on top of the ship in the form of polymorphic nanotechnology powder that accommodates itself using controlled electromagnetism. It sets itself, the ship builds itself. In other words, the powder is fed, and the ship's engines themselves put it in place around the fixed parts made modularly.
Is it poured on top of a mold, or no mold is needed?
There is no mold, just enclosing the ship in a zero-gravity vacuum. This is on the ground in Temur. The dust is fed in by cranes, and it is the ship's ignited engine and its computer that tell the nanotechnology where to position itself to form the hull and other components. But first the non-polymorphic core must be built, and the engines must already be in place. The interior is built first, and then the hull is placed on top and gradually forms on its own.
That's advanced technology, yes.
The intelligent powder is like a liquid. It is solidified by the computer with the motors as a source of energy.
Like mercury?
Yes.
And do you import any materials from outside Taygeta? Are all of the people building the ships Taygetans?
Everything is Taygetan. Some shipyards have cooperation with other races such as the Engen or the ARIEN.
And you don't? Are you self-sufficient? Your own designs and technology?
Yes, we are self-sufficient. We even export.
Do you export finished ships?
No, just the technology.